Welcome to the DIY Honda Garage channel. DTC P2101 indicates an Electronic Throttle Control System, ETCS, malfunction in the Honda Accord 2023 Plus. This cone is stored when the Powertrain Control Module, PCM, detects a significant difference between the actual position of the throttle valve and the desired position, indicating a potential fault in the ETCS. The throttle body, which houses the throttle valve, is responsible for managing the air intake into the engine, directly influencing engine performance. The PCM monitors the throttle position through various sensors and commands the throttle body to open or close as necessary. When abnormalities are detected, the PCM triggers this diagnostic trouble code. The throttle body is typically located between the air filter and the intake manifold, making its servicing an integral part of maintaining engine efficiency. The error associated with DTC P2101 refers to a significant positional difference between the actual and target positions of the throttle valve within the Electronic Throttle Control System. In this context, the PCM is responsible for monitoring the functionality of the throttle body, which plays a critical role in regulating airflow to the engine. The throttle body's position is detected using sensors that relay this information to the PCM. If the actual position diverges from what the PCM expects based on the input from these sensors, it registers the error and stores DTC P2101 as a signal of malfunction. Understanding this positional difference is crucial for troubleshooting, as it either indicates issues within the throttle body mechanism or problems within the associated wiring and PCM functionality. The location of the throttle body contributes to its importance. Being situated between the air filter and engine intake, blockages or mechanical failures directly impact engine performance. The potential causes of DTC P2101 can stem from multiple sources within the Electronic Throttle Control System. First, a malfunctioning throttle body itself is a primary suspect, either through physical obstructions, internal failures, or wear and tear that prevents proper operation. Second, wiring issues, specifically open circuits within the MTR1 or MTR2 circuits, can disrupt communication between the throttle body and the PCM. These wires are critical for delivering power and receiving feedback from the throttle body sensors. Finally, if both the throttle body and wiring are functioning properly, the issue may lie within the PCM itself, which could be failing to interpret signals correctly or experience hardware malfunctions. Addressing these causes is vital for eradicating the DTC and restoring the throttle control functionality. Symptoms associated with DTC P2101 can manifest as observable issues in vehicle operation. One major sign is reduced engine performance, which may become apparent during acceleration, leading to a lack of responsiveness when the throttle is engaged. This unresponsiveness can escalate to a situation where the vehicle struggles to maintain speed or may even stall. Another common symptom is the illumination of the check engine light on the dashboard, prompting alerts to the driver about the underlying issue with the electronic throttle. These symptoms serve as critical indicators, not only for the driver, but also for technicians during diagnostics. It is essential to address these symptoms promptly, as prolonged operation under these conditions can complicate repairs and lead to additional damage. The first step in troubleshooting the DTC P2101 involves turning the ignition to the on mode without starting the engine, which powers the onboard systems necessary for diagnostics. Following this, the Honda Diagnostic System, HDS, should be utilized to conduct the ETCS test. The purpose of this test is to verify the operational status of the throttle body and its sensors, assessing whether they are functioning within expected parameters. Engaging the HDS allows technicians to collect data regarding the throttle position and any discrepancies that may exist. This step is critical as it helps establish a baseline on the operational status of the throttle control system. Any abnormalities detected during this test will guide the technician to further investigate the specific components contributing to the DTC. The next step in the troubleshooting process involves starting the engine and taking the vehicle for a test drive under conditions that replicate those when the DTC was originally recorded. This step is crucial as it permits the technician to collect real-time data regarding various operational parameters, including engine speed, vehicle speed, and the accelerator pedal position (APP) sensor data. By evaluating these conditions while actively driving, technicians can better ascertain the performance of the throttle body and the PCM's response to inputs. Observing how the vehicle operates in real conditions will reveal if the issues manifest during normal driving or if they are isolated events. If the symptoms return during this step, it confirms that the concern is active and aids in pinpointing the exact nature of the fault. After diagnosing the components, one effective corrective action involves cleaning the throttle body. Over time, throttle bodies can accumulate carbon deposits and debris, which may obstruct the throttle valve's movement and lead to discrepancies between actual and target positions. This cleaning process is critical as it eliminates potential blockages that could cause erratic throttle behavior. Once cleaning is complete, the technician must perform the confirmation procedure to verify that the DTC no longer appears. This helps ensure that the throttle body components operate correctly and that the original issue has been resolved. If DTC P2101 is cleared post-cleaning, it indicates that the throttle body was likely the source of the malfunction, suggesting the clogging was the key issue impeding functionality. The next step is to inspect the throttle body connector, specifically the 6-pin connector that connects the throttle body to the wiring harness. This inspection must be undertaken with the ignition turned off to prevent any electrical hazards. Examining the male terminals for continuity and ensuring no corrosion exists is essential for establishing a reliable electrical connection. If the circuit appears intact, the internal circuit of the throttle body requires inspection to ensure that resistance falls below 1.0 kiloohms in the off position. Any measurements that exceed this threshold may indicate damage within the throttle body itself. This thorough inspection is pivotal as it verifies the integrity of electrical components and ensures that they are functioning in conjunction with one another without faults. In the fifth troubleshooting step, attention shifts towards the MTR1 and MTR2 wiring. Before disconnecting the PCM connector, the technician should utilize the HDS to jump the SCS, short circuit switch line, waiting for more than 1 minute to allow for accurate diagnostics. This step is essential for minimizing potential risks during the inspection process. Once the throttle body and PCM connectors are disconnected, tests must be performed to verify the continuity of the MTR1 and MTR2 circuits. Both circuits should show less than 1 ohm of resistance when inspected in the off position. Abnormal readings in these circuits signify potential breaks or faults in the wiring that may be causing the DTC P2101 to trigger. Addressing such electrical issues is critical for restoring optimal communication between all components involved in the throttle control system. If previous inspections yield normal results, the focus must shift to the PCM itself. The PCM, or Powertrain Control Module, is a vital component that acts as the brain of the vehicle's engine management system. It processes inputs from various sensors and sends signals to control functions, such as the throttle body. To confirm PCM integrity, the technician should check for any stored codes or malfunctions that stem from the module. If the PCM exhibits signs of failure, it may not accurately communicate with the throttle body, leading to the DTC P2101 being triggered. Identifying a malfunctioning PCM is vital, since it implies that all other components were functioning correctly, yet still reported errors due to PCM issues. In such cases, PCM replacement or reprogramming may be required to rectify faults within its system. Final repair verification is essential after all diagnostic and repair actions have been performed regarding DTC P2101. This process initiates by ensuring that all previously identified issues have been resolved and that the electronic throttle control system operates as intended. The technician needs to use the HDS to confirm that no DTC P2101 appears post-repair, indicating that the originally identified fault has been rectified. If verified, the technician will conduct a summary of completed repairs and prepare the vehicle for return to the customer. This ensures transparency regarding the service performed and fosters trust in the automotive service. Open lines of communication regarding potential maintenance or monitoring specifics can also reinforce the customer's awareness in respect to their vehicle's operational health. Preventive maintenance is crucial for avoiding DTC P2101 and ensuring the longevity of the electronic throttle control system. Regular throttle body cleanings can help prevent the buildup of carbon deposits, dirt, or obstructions that may hinder smooth operation. Addressing these potential issues before they manifest into larger problems can save time and resources in the long run. Additionally, routine inspections of the wiring associated with the throttle body and PCM will help catch any frayed or damaged wires that could disrupt electrical communication. Staying proactive in these areas empowers vehicle owners to maintain optimal performance and ensures that systems continue to function within specifications. Keeping an eye on the throttle control system's health can significantly enhance the driving experience. In conclusion, DTC P2101 signifies a malfunction within the electronic throttle control system of the Honda Accord 2023 Plus, demanding thorough diagnostic approaches tailored to the throttle body and associated components. Each inspection step is critical for isolating the issue, whether it stems from the throttle body itself, wiring incongruities, or a malfunctioning PCM. Such careful, methodical troubleshooting ensures not only that the DTC is resolved, but also that overall vehicle performance is optimized. Implementing preventive maintenance practices, such as routine throttle body cleaning and wiring inspections, is instrumental in preventing future issues. Ultimately, staying proactive in maintenance improves vehicle reliability, ensuring a better driving experience and reducing the likelihood of unexpected malfunction. Please like and subscribe to the channel. See you next time!